Okay, so welcome to the last lab of the block, Unit 6, Stoichiometry lab. So, like the rest of the videos, we'll start by getting the online equipment or things that you'll need for the lab. And again, two places you can get it. You can get it from class content, clicking on 6, scrolling down to 6.09, or from the plan, which lab, I believe, shows up actually in March. It registers that I want to move ahead a month. So 6.09, there we go. Click more to see everything. So, and like the other labs are similarly set up, the lesson introduction is just a very basic introduction that does give you a materials list, but that's also in your lab manual. This one here is more content-based, so you'll want to take some notes on that laboratory page. The recording that I'm making right now will go here. The investigation has the link to the virtual version of this lab, and for this lab, they are actually identical as long as the virtual version uses the same chemicals. But again, this is a hands-on class. It is required for you to be doing the hands-on labs. So that's more of a backup just to make sure everything's going right, that sort of thing. The lab report that you're going to turn in is going to be in this first Dropbox area, and then you'll have to submit that proof of completing the hands-on lab in this second Dropbox area. So let's get the lab report. Nice. Make sure you have that downloaded and handy on your computer. We will come back to this when we're done just to talk about the lab. But let's move to looking at the physical materials that you're going to need. Okay, so one, make sure you got your lab manual. It's on page 21. Okay, 22 has the materials list and the actual experiment procedure. You do want to read everything else though beforehand. So we want to be wearing our safety materials, so gloves and goggles, those should be on. Then the 2 microplates you can see here. The toothpicks are an alternative to using the one stirring rod and having to clean it off after every time. Okay. And then the chemicals that you're going to need that sodium hydroxide bottle that we were using in the last lab, in the Unit 5 lab. Right, so it should be 0.1 molar sodium hydroxide. Right, it's one of the slightly bigger bottles. And then there are 3 chemicals that should say with phenolphthalein. Okay, so these were all bigger bottles. The copper, it says cupric nitrate with, and then there's this really crazy long word that starts with a PH, that's phenolphthalein. Okay, so you want cupric nitrate with phenolphthalein. You want iron 2 sulfate with phenol, and this one actually doesn't have the phenolphthalein written totally out, but it is PHENOLPH, so abbreviated a little bit. And iron 3 nitrate, also with the phenol. Okay, so make sure that you have those ones that have the phenolphthalein in there. What phenolphthalein is it's an indicator that lets you know that what you're working with is basic, right? So it's a base. Sodium hydroxide is a very strong base, right? So the sodium hydroxide will activate the phenolphthalein as long as there's still sodium hydroxide in solution. If we reach the point in the reaction where sodium hydroxide is our limiting reactant and we use it all up, then it won't turn on that phenolphthalein indicator. All right, just so you kind of have an idea of how that works. So what we're going to be doing is running 3 different reactions and changing the amount of our 2 reactants to see what that does to the amount of product that we make. So this is why this is a stoichiometry lab. Okay, so You're on page 22 looking at part 1, collected materials. Go ahead and create that data table. That's going to come in handy for organizing your thoughts later. All right, so with well number, drops copper, drops sodium hydroxide, we're going to have 9 wells for each of these experiments, and we're going to do 3 of them. Okay? And then place 2 microplates next to each other like we have. You're going to want to write out your chemical formulas, which I'll do that with you on the first one at the end once we have everything on there. And then the procedure using the 9 microplates that you identified by letter and number. Place 5 drops of CuNO3 in the first well, then 10 drops in the second well, 15 in the third well, and so forth. And then we're going to work things backwards. So just to kind of write this out for you a little bit, if you think about our wells, make sure you can see them all. All right, so we have A1, A2, A3, A4, A5, A6, A1, A2, A3. Those are the ones that we're going to use. All right. We're going to have drops of, what does it tell us to put in first? The copper nitrate. All right, so we have the CuNO3, 2. We're going to do 5 drops, 10 drops, 15 drops, 20, 25, 30, 35, 40, 45. All right, and then we have sodium hydroxide, NaOH. And what we're going to do is we're going to do these numbers backwards. Okay, so go 5, 10, 15, 20, 25, 30, 35, 40, 45. So if you notice all of these pairs of numbers, 5 plus 45 makes 50, 10 plus 40 makes 50, 15 plus 35 makes 50. They should add up to a total of 50 drops. So we're always going to end with the same volume. It's the amount of reactants, the proportion of the 2 reactants that changes. All right. So this is going to take some counting. You do need to be really careful about making sure that you get these numbers correctly. There's only 5 drops of difference. So if you're getting extra ones in there, you're going to have to redo. All right. So it's possible you might run into that. All right. So let's do this first one. I'll do the whole first one with you. Alrighty, so here goes my hopefully very careful dropping. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5. All right, now 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. All right, 35. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5. Then we're going to go 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, and 45. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. 1, 2, 3, 4, 5. Okay. So that used up a fair amount of my copper solution here. So what I'm going to say, because I'm concerned, I wish they had sent more of the sodium hydroxide, go ahead and use what I get here as your data for the copper nitrate, and then you'll just have to do the 2 iron solutions on your own. Okay? I am very concerned that there's not actually going to be enough to complete this whole thing. Hopefully I'm wrong, but we may run into that. All right. So now we do the exact same thing, but 5 at this end, 45 at the other end. So I'm going to start from the other end so that way it gets shorter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5. Oops, I actually got an extra one in there, but luckily this one, being the far end, is actually okay. So, I don't know how well you can see this, but I think you actually kind of can. You can see that there are some kind of like thicker areas of the blue, and that's a precipitate forming. Okay, so we get a little bit of precipitate forming, not much, but a little bit, with 5 drops of the copper solution and 45 of the sodium hydroxide. Alrighty. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 31, 2, 3, 4, 5, 6, 8, 9. So there's 40. At the end, I'm going to go back and stir all of these, but you can see reactions are starting to happen, because when it starts to get bluer, that's because it's making that kind of darkish blue precipitate. All right, 35. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20, 10, 30, 4, 5. Now 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 30 down to 25. 1, 2, 3, 4, 5, 8, 9, 10, 11. That one didn't drop, it actually just fell on the table, so I gotta remember to clean that up. But 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, good. I want 25. 2, 3, 4, 5, and 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then 15. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. Now 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 5. 1, 2, 3, 4, 5. Okay, so let's stir these. Now I am going to have to rinse off in between each one because I don't want to change the proportion of my chemicals. All right, just to make sure that everything that can react has reacted. So I'm just going to leave my water running so this goes a little quicker. Sorry about the noise there. What you're actually starting to see here is the effect of the phenolphthalein. At the starting where it starts to kind of turn this whitish blue, and it's getting lighter, that's when you reach the point where your limiting reactant has switched. And it is now the sodium hydroxide instead of the copper solution. All right, so that's actually really nice. This is a feature that the online lab didn't have. So what you can see here is that it progressively makes more and more precipitate. And then when we get to our fourth trial, our fourth well, so 20 drops of copper nitrate and 30 drops of sodium hydroxide. So somewhere between these two, the 15 and 20, the 35 and 30, is when we reach that perfect point where we're using up all of the sodium hydroxide and all of the copper nitrate. Okay? So it might be one of these two well, it might be this well, or it might be somewhere in between the two. And what we're going to do is we're going to see if it actually kind of matches up with our reaction. Okay? So this is going to tie into some of the questions that you have to answer. So for part 1, describe the changes in colors of the well, if any, as you go from well 1 to 9. That is, as you go from well, which has the least copper nitrate, to the most copper nitrate, which had the most distinct precipitate. Okay, so looking at our wells, we can see the most precipitate probably in the third well, which was the 15 copper nitrate and sodium hydroxide. And we know based on the change due to the indicator that in the fourth well, we've gone from having excess sodium hydroxide to using it all up. Okay. So those are some observations you can make about the first experiment, and then something similar to this should happen in the rest. And then question 2. So then you'll do that again for part 2 and for part 3. Just describe what you're seeing, focusing especially on when you know you have the most product being made, so the most precipitate, and when your limiting reactant changes, because that's why you're reaching that kind of almost equilibrium point where you're actually using up both reactants completely. So below are the valence equations for the reactions part 1 through 3. Review the results of your experiments and look closely over the mole ratios. Do your experiments reflect stoichiometric molar amounts indicated by these reactions? Discuss using evidence from your experiments. Okay, so that's, I'm going to copy down our equation here. Marking off the two areas where we know we have the most precipitate. So it is Cu NO3 plus 2 NaOH yields Cu OH2 plus 2 NaNO3. Okay. All right, so if you look at our two wells here, we know that by the time we get to the fourth well, we have switched limiting reactants, right? Which means possibly at this very moment or somewhere between these two, we reached the perfect molar ratio where we're using up both reactants completely, all right? Now that perfect molar ratio, according to our equation, is that we should have a 1-to-2 ratio of your copper nitrate to NaOH. All right, so we should have twice as much sodium hydroxide as we should copper nitrate. If you look at our numbers here, all right, so A4, you actually have a little less than twice as much of your copper nitrate, all right, which is why you start using up your sodium hydroxide completely. Right? Well, if you look at A3, 35 is slightly more than twice as much of the copper nitrate, right? Which is why copper nitrate was our limiting reactant here, right? But that does match because somewhere between these two, you're actually going to reach that 2-to-1 ratio. We just didn't hit it head on because we were counting by 5, right? So the way I would explain this is that 30-to-20 is slightly less than that 1-to-2 ratio. 35-to-15 is slightly more than that 2-to-1 ratio. And we can see that there's a change in limiting reactants from this trial to the next. So yes, this does match with the expected molar ratio from the equation, right? Because we see the change when we are in front of the ratio and then after the ratio. Something kind of like that, right? But the big thing is you have to use evidence from your lab. You have to address these two wells, what their ratios tell you about surrounding this molar ratio from the equation, okay? And then do the other two experiments, the two iron ones, and see if you find you'll probably have different molar ratios, so it'll happen in different wells, but see if you end up confirming the molar ratios on those reactions as well.